Okay, so good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. My name is Francesco Petruccione, and today I'm really excited because, you know, we are trying a real hybrid format. Yeah, so we have the Stellenbosch node of NITheCS in the Nielsen cinema, and we have WITS participants in some honors room at WITS, probably in the physics department, I'm not sure. Yeah, so these are really very nice experiment. Thank you very much, Joel. And we have also participants online in front of their own PC or laptop. Yeah, Joel, can I ask you to please introduce the speaker?
Yes, so as Francesco has indicated, this is our first attempt to organize colloquia that fall under the NITheCS banner, but being centered, if you want, here at WITS, which is supposed to be the head of the node in the Gauteng region. So today I'm very pleased to introduce Dr. Boitumelo Moletsane. She has the title of a talk, Use of Poetry to Foster Inquiry into Mathematics. She's a lecturer. She's been at WITS in the School of Mathematics since 2014, and a lecturer since 2019. She wrote a PhD with Professor Mola in functional analysis, and has carried out research projects in semi-groups methods in partial differential equations, as well as study techniques. So thank you very much. Please welcome. I'm very pleased to welcome you here, and we look forward to your talk.
Thank you. Okay. So today I'm going to share with you how we have used poetry to try and foster the mental inquiry. So I have been teaching this one for 10 years, and the campus that I've been teaching has been a course that is requirements to a number of degree programs. And what I observed over the years was the lack of joy that students experienced from the course and the frustration with the course. And I wanted to explore an avenue where students could at least, even if they don't do well in the class, but they could at least enjoy the subject. So I initiated this math poetry workshop last year with two other colleagues, a South African poet named Robert Russell, and a fellow from the Writing Center, poet Ashmore. And we ran about 4 workshops, and we had tutorials where students could define the poetry. And it was only towards the end that I realized that probably what we were trying to do falls under the educational research framework called universal design for learning. And universal design for learning is a term defined by David Rose at the Center of Applied Special Technology, which is, so I'm going to read, it is a framework to improve and optimize teaching for all people on scientific impact on how humans learn. So you can have a look at their website, past which is Center for Applied Special Technology. And universal design for learning has 3 principles. And one of the principles is engagement. And engagement speaks about the different ways in which different learners are motivated and engaged. And in the South African context, we know the diversity of learners that come into contact with when we in our different disciplines. And it would be near impossible to expect that a different mold, a single mold of engaging learners would work for all of us. The other principle is that of representation. So learners differ in how they perceive and communicate. And so multiple representations of information it's important to be able to capture as many areas as possible. And the third principle is that of action and expression. So this captures the idea that learners need to have avenues to be able to express what they know in more than just one way. And I think for the past 10 years that I've been at Bern, the ways in which we determine if the learner knows has always been just pen and paper. And these principles, for me, when you look at them, I mean, representation, engagement, action, these are the principles for me that speaks to democracy. And democracy in mathematics has been a subject that was talked about by the Sadlerian professor. This is Professor Hobson, who was a Sadlerian professor between 1910 and 1921. And at his presidential address to the Mathematics Association in London, he spoke about democratization of mathematical education. And so I would like to read an excerpt from his speech that you can get from online. And so I would like to read it because for me, I think it speaks to what we think is, okay, what many may think is a situation in mathematical education that is peculiar to South Africa. But democratization of mathematics has always been a subject in many other countries and spheres. So the modern, now we speak in Microsoft, the modern tendency which has asserted itself in our time in greater or less degree in all countries in educational policy may be described as the tending towards the democratization of education. This term, or some synonymous one, general sense that I intend here to employ the expression I mean by rather the progressive adaptation of educational methods to the intellectual democracy, the transformation from the methods of teaching and from the method of instruction so as to meet the needs of those who are lacking with exceptional capacity. At least in relation to the particular branch of study question. In other words, the concentration on the attention object in a much greater degree than formerly on the work of developing the mind of the average many, and not solely of those of an exceptional individual. So I think for me this speaks to me a lot because I think the concept of trying to make mathematics accessible to many relates to sustainability. Okay. All right. Okay. So there's a mathematician, Alexander Swan. Alexander Swan, when we can look at his the math profile, he has published about 42 projects. And he, in this book published by the American Mathematical Society, he tried an experiment with 4 children. One of the children was his Dimitri Born, who is now a mathematician. Paris, the director of research in a place called Science Paris. And in his book, he explains the concept of a mathematical circle. And one of the things that I like about this book and that impresses me is that in this book, when he was talking to children less than 5, the first activity in the book is that of demonstrating the properties of demonstrating the movie script. And I myself, as a product of South African mathematical education system, the first time I saw a movie strip was in 4th year. And if you think about it, I mean, in this book, he makes it explicit that the content and the activities that he predicts do not require a child to be able to write a child must not be able to write in order to be able to engage in the activities that he currently does. And yes, the first activity here is in the picture. And so I give a picture here because this is a picture of the 5 children that were part of a mathematical circle. And the concept of a mathematical circle, he described it as an Eastern European idea where you have a group of people with varying degrees of proficiency in the subject with different backgrounds and not necessarily in the same topic come together. And there's a term that is used by another mathematician called Joel Hamkins, where I would say that those skills are called social performance activities of the phrase. Like if you break down the phrase social performance activities of the phrase, it means you have society, which will be represented by the word social phrase, performance. And for me, when I think about performance, I'm thinking about theater. So it means there's gesturing, there's emotion, there's articulation, and all those things. And those are the activities that I think would be part of the activities of what Alexander wants to call the mathematics circle. So now I spoke about in the abstract about the issues of language and mathematics. And there's a number of, Alexander himself speaks about mathematical instinct. And there's another writer, Steven Pinker, who speaks about the language instinct. So a lot of people make the relationship between language and mathematics, even though one can say that you require more to be able to become proficient in mathematics. You require more of your mathematical instincts than you would require the language instinct to be able to be proficient in a language. So this framework of multiple intelligences. So this speaks again to in the principle of engagement and representation in the universal design framework. That there's a theory that people have multiple intelligences and subsystems within their brain in which they synthesize and comprehend information. And again, there's another, okay, this is Jacques right here in the French philosopher seminar, who speaks about equal intelligence. And the ethos or the premise of his thesis is that if you start off with the idea that whatever you are presenting to people, people are of equal intelligence, rather than looking at equal intelligence as the end product of what you are doing, so that people and for example, if I'm a teacher and I have students, and I think that it is my role as a teacher to move students from a particular level of knowledge to where I am, instead of as being the end product, as opposed to assuming equal intelligence from the outset. And he speaks about it in his the ignorant schoolmaster, the party end of the game, intellectual emancipation. So I guess I'm reversing a little bit, but I think it's something that's important too. So during the workshop, the last workshop, we met a Chinese mathematician called Cai Tianxin. He's a mathematician and a poet. And he wrote this brief history of mathematics. And so I'm going to illustrate in, okay, so this is a bit messy, but I'm going to illustrate how representation of the same information might have different effects. So let's think about Russell's paradox, for example. So, okay, there's a lot of words on the screen, but the Russell paradox can be presented in a formal way. Say, sets that contain itself. So you have a collection of sets that contain themselves and those that don't, and then you come to a contradiction. And this is the statement as it would be written. And this statement here was made by everybody. But the very same statement by the same person in 1919, he says, consider a village law which is all those who do not shame themselves, that is about shaming itself. So this is the same statement represented differently. And I think you're more likely to capture the attention of more people for the second statement than you would otherwise for the one that I presented before. And the Russell's paradox is considered to be the third crisis in mathematics after the discovery of the irrational numbers and the infinitesimal, which was solved by the Cauchy's limit theory, and the Russell's paradox, which was mediated by Boitumelo and Frankel. And so this was a very important statement in mathematics that so it's a statement of significance. But it was, so the picture that I have here is a picture of curved Gödel. So the statement of Russell's paradox, which shook the foundations of that theory, was sort of mediated by curved Gödel's two incompleteness theorem. So let's look again at the instantiation of Gödel's first incompleteness. So let's look at the statement. So the first incompleteness theorem says any consistent formal statement as that is strong enough to carry out basic arithmetical numbers contains statement S such that S and its negation are all proved. So this is what the statement is. And then we have another one. In F, the second one. In F, we are consistent formal system strong enough to think the natural number system, then consistent with activity. But these statements here, they're just statements. But in Cai, so the Russell's paradox brought about three schools of thought in mathematics. For one of them, logicism, intuition. And when Gödel proved these two theorems, they say that he put a stop to the idea that human intuition could be completely axiomatized. And I think if you think about the statement of, which has been paraphrased by Cai, that human intuition cannot be completely axiomatized, in opposition to this two statement of Gödel's theorem, I think you are more likely to capture attention of more people into mathematics logical, maybe the discipline of mathematics. Now, in South Africa, we are faced with the issue of a lot of students, a lot of us who teach and learn mathematics. We learn mathematics. Most of us, the language is not our mother tongue. And there's research, even though it's carried out on young children. This is research by Richard Brown on the English additional language speakers in the UK. And they say that from their research, which was a 3-year study, it took 2 years for students who were non-English language first speakers to acquire proficiency. But it took much longer for students to acquire proficiency in expression of rhetorical concepts in English. So I'm going to share with you a poem that was written, or a part of a poem that was written by some of the students who participated in the workshop. I mean, I'll share maybe these two samples, and it's the computer science student who who was doing computer science, and she shared that the parents would not find studies. She was to do that if she was to major in math. So instead, she had to take computer science because there was only way she could take computer for parents. And she wrote this poem here. And one thing about poetry is that oftentimes poetry is not noetic. So it doesn't appeal to the intellect, not always, but oftentimes. So you often express your emotion, and I think for most people, we can write about how we feel. We can write about how we are affected. We can speak about it. And we did encourage that students write in other languages, in other tongues, so that they are able to express themselves more fully. And unfortunately, we only had about one submission being suited about the poem. But something happens because just like with the idea of the mathematics circle, and I also want to share, the idea of the mathematics circle, Google was also part of the Vienna mathematics circle. So the idea of the mathematics circle is you work in community, not alone. And in the math workshop, students were working in groups. And what happened was that as we had more workshops, students started getting, but we didn't have a criteria, anyone could come. So this was an extracurricular activity. It was not part of any formal program. Students started getting to know each other, and from this poem, another student decided that they're going to interpret the poem as an animation. So this was work done by a student in the fine art who attended some of the workshop. And I just wanted to play the video to show you the interpretation of the poem by a student. Okay, I'm going. Okay. So these were all, one could say, initiated by students. So the animation at the moment doesn't have any sound, and the idea was that should we continue the workshops, the students would then come together and create a script. I mean, if you remember the title of the poem that the student wrote, it was about a sphere and a cube. And if you look at this animation by this self-taught student in 2D. So interpreting that and trying to come up with original content, for example, one could look at possibly exodometry. But there was, okay, so I have intended to look at activities that could be done. I mean, some of the activities I learned from the Institute of Writing and Thinking, perhaps using this book by the Sanderian professor person to create a script, because this book here is a 57-page book, and it speaks about the history of the problem of square root devil. And that problem is said to have 3 areas in mathematics, from the approximation of pi by the ancient Greeks and Egyptians to the start of analysis in the 1700s and 1600s, and to now knowing that E and pi are irrational numbers. So I had thought that perhaps one could engage students in some of the activities by using words from the book to create a narrative, or to create a script for the animations that are interpretations of poems. So this is one way of doing it, but as I got to learn last year, and the students can have some very brilliant ideas that students never thought of. But there's another. So now, in conclusion, there is this book by Edward Frankel, and this book demonstrates all the 3 principles of universal design in the experience that he chronicles of the sessions that were hosted by Witwatersrand at the State of Moscow University. So he speaks about every Monday night at the University of Moscow, undertaking for mathematicians from different disciplines of mathematics would convene and speak about mathematics. And from that group, I mean, there are many mathematicians who came out to publish work of significance in mathematics, and I think Edward Frankel is one of the students who benefited from the setup of having multiple different representations, different ways of engagement, and expression that is not limited to just pen and paper. Because people, you realize that, okay, not to realize that at the State of Moscow, they had actually at the State of Moscow University, they had 3 criteria in which to gain admission to the university. You wrote a test, you wrote an essay, and you made a follow-up presentation. And all those principles are some of the things that speak to universal design for learning. So I'm going to stop talking. Thank you.
Very much. On the see, are there any questions? I'm curious. So you mentioned from time to time discussing this with students and students having ideas. What cohort of students were these? Were these taken from your first-year calculus schools, or is it a different type of students?
So, okay, so I would sometimes I'm high, so I would do focus around campus. And anyone who wanted to come to campus, I mean, students from others, they came from, we had some coming from outside of campus who were master's students. Anyone could come. So it was, I would just put focus around campus and people came.
All right. So, and calculus is what, 500 students at least?
No, actually 1,000
students. Are you in any way able to implement or think when you teach any of these general concepts that you have discussed here, or is it just not practically possible? Does it inform the way you teach?
I think it's one of the reasons probably for me to do these workshops was also out of my own frustration, because I think the teaching and curriculum is really regimented. So it was also sort of in response to my own question.
Francesco, I don't know if you want to ask, if anyone online wants to ask questions.
Yes, Joe, thank you. We have some questions here. Please. Use this one here.
First of all, thank you so much for the lecture. My question is about, well, in the South African context, with so many languages that we have, do you think it's useful or feasible even to try and, for example, have classes in all the different languages or write exams in all the different official languages we have? Because I know in 2019, I think you could write your matric exams in Xhosa in the Eastern Cape. So do you think it's feasible, because realistically, the lingua franca of academia is English?
Actually, there are over 7,000 languages in the world. And if you go to Google Translate, I think except maybe for languages that have Cyrillic, like Russian, when we try and put Russian into Google Translate, you're most probably not going to get something that is comprehensible. But even Russian, like languages like, Arabic, for example, if you put text into English to Arabic or Arabic to text, you're most likely to get something sensible, but I think it's purely from the number of Arabic speakers. So I think the issue of language is slowly dissipating as a barrier. And I think it's a benefit and an opportunity for mathematics, so that mathematics isolates itself, maybe possibly as a language itself. So I don't think with the current technologies, language should be an issue. Most of the mathematics that we learn, the Euclid's Elements was written in Greek. Most of the mathematics, if you Fourier analysis, Lachelot theory is written in French. Most of the mathematics that we learn is translated. So translation is not an issue. The book that I showed of Cai Tianxin. Cai speaks very limited English, but yet his book is translated from Chinese to English. So I don't think the issue of language is something that is that much of an issue.
Thank you. Are there other questions on this? Here we go. Just a second.
Yes, thank you very much for the presentation. I always had the impression that poetry is more difficult than mathematics. And you have to spend more time trying to find out what the poetry was trying to say. So if we go down the road of poetry, we want to actually bring mathematics to life. So I just want to find out, won't that make mathematics more difficult?
Thank you.
I think it is Hardy, Hardy, who wrote a lot of poetry. And he has a phrase about, well, there's a conversation, I can't remember the interlocutor, who's also a poet, and they speak about Asclepius and, this idea of ranking disciplines. Poetry is poetry. Mathematics is what? Mathematics. And if you try to find relationships between them, probably maybe that is another relation or another association that you could make. But we are not saying that we want to replace mathematics with poetry or poetry with mathematics. That's not what I'm trying to do here, but I am trying to sustain engagement with the subject matter so that students use different techniques, for example, because I think if you're engaged, and engagement often involves emotions, it involves senses, you're more likely to sustain your attention into inquiry that requires more intellect and cognitive capacity. So we are not trying to turn mathematics into poetry or poetry into mathematics.
Thank you. Any other questions from this side of the colloquium? No? Joao, it seems that we don't have any more questions from this side. So back to you. Thank you.
Then it's just left to again thank the speaker again for an excellent talk and very inspiring. Wish you well in your continued attempts to find a broader framework as around physics research and teaching. Thanks very much.
Thank you very much.